Okay, so today I wanted to talk about greatest common factor and lowest common multiple. Now, I did do a previous video on this, but the method that I taught in the previous video is kind of a brute force method. So we're going to go through it again using a better method. So greatest common factors and lowest common multiples. 2. All right. Okay, so first of all, I'm just going to review the other system that I had gone through before. With the other system, what you can do is you can take some simple numbers. So let's say something like 6 and 7. Okay, and then what you can do is if you want to find lowest common multiple, you can just start listing multiples. So 6, 12, 18, 24, 30, 36, 42, 48, and so on and so forth. With the 7, you can go 7, 14, 21, 28, 35, 42, and 49. And oh, look, there's a match, and there's a match. And so then you know the lowest common multiple is 42. Now, this method's okay. It's kind of a brute force method, and it will work, but sometimes it just takes a long time to find anything. That's for lowest common multiple. For greatest common factor, it's also, I'll give you another example, it's easy just to list all the factors of something and compare them. Okay, so for instance, let's say we were looking for 24 and 32. Okay, so 24 is 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. Okay, 32 is 1 and 32, 2 and 16, 4 and 8, and that's it. Okay, so then we just look and see which is the greatest one that's the same, and we find that the greatest common factor is 8. Okay, now this all works well and good for simple numbers. Okay, but what if the numbers aren't that simple? Okay, what if the numbers were like 516 and 722, right? And you're trying to find the greatest common factor between them. Well, it's not going to be that easy because the factors of those numbers aren't readily apparent. Okay, and you could get numbers where there's tons and tons of factors, and it might take you a long time to find them all, and then you'd have to do a whole bunch of long division and stuff like that, which makes things really difficult. Okay, so instead, what I'm going to show you is how to do how to find greatest common factors and lowest common multiples using a factor tree. Okay, so I'm just going to start with a simple example, and I'm going to use 24. Okay, so 24 and 54. Okay, now 24 is 2 times 12. Okay, so I'm going to circle the prime factors. Okay, 12 is 3 times 4, and 4 is 2 times 2. Okay, so what we can say is that 24 is equal to 2 times 3 times 2 times 2. Now 54, on the other hand, is 2 times 27. 27 is 3 times 9, and 9 is 3 times 3. Okay, so when we're finding greatest common factor, okay, so greatest common factor, we're going to ask an important question. Okay, and that question is, if you just give me a moment here, what is the same about these two numbers? Okay, so what's the same about them? Well, let's take a look. Okay, well, they both have a 2. I'll just do this in a different color. So they both have a 2. Okay, they both have a 3. Okay, and that's it, which means that they share factors of 2 and 3. Now, if we combine the factors, we combine them through multiplication, and we get 6. Okay, so that means that if you combine all the factors that they have in common with each other, you get 6, which means that the GCF, the greatest common factor, is 6. Now, to find the lowest common multiple, we need to consider not only what's the same about the numbers, but also include what's different. Okay, because the lowest common multiple of these two has to be also a common multiple of its greatest common factor. But how much of a multiple of its greatest common factor? And what we do is we look at the differences. Okay, so what we're going to do is we're going to consider a different question. Okay, so this is the lowest common multiple question. Okay, so let's go to black. Okay, so lowest common multiple question. Okay, and that is what is different about these two numbers. Alright, well, let's take a look at what's different. Well, first of all, we have a 2, okay, and I'll circle them in red here, or go to blue. A 2 and a 2. Alright, so we have a 2 and a 2, and a 3 and a 3. Okay, now that's the factor, those are all the factors that are different between them. So 2 times 2 times 3 times 3. Okay, so 2 times 2 is 4, times 3 is 12, times 3 is 36. Okay, now what we have to do then is we know that the lowest common multiple has to be a multiple of 6, right? Because 6 is the greatest common factor of both of these. Well, how much of a multiple? Well, it's this. It's 36 times 6. Okay, so it is the LCM is equal to the GCF times the differences. Okay, so that's 36 times, or 6 times 36. 6 is the GCF, 36 is the differences. Okay, and that gives us, let's see, 30 times 6 is 180, 6 times 6 is 36, so 216. Okay, and that is our LCM. Okay, it gets a little bit more complicated though when you're using multiple numbers, and I wanted to go through an example of this. Okay, so let's take a look. I'm going to use the same numbers as before, but I'm going to add one in. Okay, so I'm going to take 24, 54, and now I'm going to take 45. Okay, so let's just start again quickly. Okay, so 24 is 4 times 6. That is 2 times 2. 6 is 2 times 3. 54 is 2 times 27. 27 is 3 times 9. And 9 is 3 times 3. Okay, now 45 is 3 times 15. 15 is 3 times 5. Okay, so now if I'm finding the greatest common factor, okay, remember I'm going to ask, well, what's the same? Okay, so I'm going to, once again, I'll do this in green. GCF. Okay, so what's the same about these? Well, let's see. Now, they no longer, the 24 and 54 share a 2, but the 45 doesn't anymore. So the only thing that's the same is a 3 here, a 3 here, and a 3 here. That's the only thing they have in common. So now the greatest common factor that they have is 3. Remember also that if none of the factors match, that the GCF can still be 1. Okay, well, what's the lowest common multiple? Okay, so for the lowest common multiple now, we're going to have to consider what are the differences. Okay, let's take a look. Okay, sorry, I'll just do that in blue, do it in blue. Different factors. Okay, let's take a look. Well, let's see, I've got a 2 here. Okay. Now, here's the thing. This is where it gets a little tricky. This 2, I'm going to count it, but it's the same as this 2. So basically what I can do is I can take away both of those 2's. Okay, even though I only counted it 1 here, it's because it's already counted for each one. Okay. Now on this number I've got another 2. Now I can't count that anywhere else, so I just have to put that there. Okay, and another one as well. Okay, so there's 3 2's that are different. Now it looks a little weird because there's 4 in the diagram, but it's because this 2, okay, I'll do it in orange. Okay, this 2 is the same as this 2. Okay, now what else is different? Well, we have a 3. Okay, now this 3 is the same as this 3. Okay, so I only count it 1 time. Okay, this 3, okay, also needs to be counted, but it can't be crossed off with any other 3's because it's all alone. Okay, and this 5 is all by itself as well. Okay, now I don't count any of the other 3's that were in green because they were already counted in the GCF. Those are the similar ones. Okay, so my different factors are 2, 2, 2, 3, 3, 5. Okay, so when I multiply these together, okay, let's see what we get. We got a 6 there, another 6, and a 10. Okay, so the way I did is I said 2 times 3 is 6, 2 times 3 is 6, and 2 times 5 is 10. So then we just multiply these. I'm going to say 6 times 6 is 36, times 10 is 360. Okay, now remember my LCM is equal to my GCF times the differences. Okay, so the GCF is 3, the differences is 360, which means that my LCM is 1080. Okay, and that's how you do it. Okay, so hopefully that's a good supplement to the other lowest common or greatest common factor and lowest common or lowest common multiple video that I did. If you have any questions, please put them in the comment box. And yeah, if there's any math problems you have difficulty with, please feel free to make a suggestion. Maybe I'll make a video about it.